In this media, you are going to learn about analysis of lubricating oil, laboratory analysis and tests. This figure schematically shows the appropriate location for collecting lubricating oil samples for the tests explained in this media. Lubricating oils cannot continue ever in satisfactory service on account of two basic reasons. 1. Oxidation or other chemical changes in the lubricant. 2. Contamination due to ingress of foreign materials or debris of materials from moving components in service. This can be verified by way of laboratory analysis by using a lubricating oil sample of around 0.75 liters in a 1-liter jar. Some parameters of the lubricating oil which need be examined in the laboratory are viscosity, flash point, total base number, water and products of oxidation. Viscosity. As per the ISO, around 18 viscosity intervals from 1.98 centistroke to 1650 centistroke at 40 degrees Celsius have been assigned for lubricating oil. If the viscosity of the lubricating oil has increased during use, it signifies oxidation or aging or high carbon content, and this leads to a fall in the lubricating properties of the oil. Dilutions by the contamination of fuel oil or water, unless an emulsion is readily formed, leads to a fall in viscosity. A significantly lower viscosity will cause the oil film thickness to reduce and lead to excessive wear and scuffing on parts like liners or highly loaded journal bearings. Flash point is the lowest temperature at which the lubricating oil produces a combustible vapor. In other words, concentration of air to lubricating oil vapor mixture, which can be ignited by a flame or spark. This is estimated by the Penske-Martin test or by the Cleveland apparatus, having closed and open cups respectively. TBN, total base number. The TBN is a measure of the reserve alkalinity of a lubricant. The test is relevant to diesel engines due to the need to neutralize the acidic byproducts of combustion, particularly those with high sulfur content, generated when diesel fuel is burned. Water. It is always undesirable since it can lead to unwanted emulsions, corrosion, and oil additive deterioration. Usually, tests by adding xylene is carried out to separate water and to trace the source of the water. Products of oxidation results from overheated lubricating oils or contamination with partially burnt fuel oil. Formation of these products in large amounts must be removed to prevent gummy deposits on various parts of the engine. Usually, the infrared analysis method is used to assess the amount of oxidation products in used oil. This concludes the short video on analysis of lubricating oil.